Hi, today let me talk about the procedure and function calls in free Pascal. So this I already showed in many tutorials, but never really went through how you can define procedures or functions within free Pascal. So I collected here all the options. And I can say that basically defining procedures and functions more or less the same. The only difference is that while a procedure is basically not let's say mean to be used for passing variables back and forth or passing a result of the procedure back to the caller, but of course you will see that it's possible with the procedures as well. However, functions are always let's say providing a result um, as as a typed result. So when you are using procedure, you can't use them, for example, in write-ln command, but a function you can use because basically it will be uh, interpreted as a type itself, which is represented by its result. So let's go through how you can define the procedure. So the most simple procedure or function declaration is where you are not defining any parameters for the procedure or function. So here you can see that if you just name the procedure and you are not adding anything to it, then of course this procedure will not get any parameters, so you can just use it to do certain let's say program code and work with this program code, making writing something out, or even can use of course global variables and modify global variables as well. But you are not passing these variables directly to the procedure or to the function, but you are taking it from the global variables themselves. The next option is when you simply define a parameter which the procedure or the function will use. But basically, this variable is just passed to the procedure or function, and then the code inside is taking care about handling this variable and doing something with that. So here I just simply writing it out with a write-ln command, and that's all what this procedure is doing. The next option is when you are defining a variable with the var statement here, and this will tell to the compiler that this variable passed to the procedure, and also the procedure is modifying back the original parameter with the result inside of the procedure. So in this case, when I'm passing a variable to this procedure, it's basically adding 1 to it, and this increased integer number is passed back to the caller. Later on I will show how this works when it is called. So then the next one is for a simple function. So here I defined two functions just to show that when you are defining a function, and even if you have parameter or you don't have a parameter, it doesn't matter. At the end you can pass back the result of the function with let's say calling or making the function name itself like a variable, and attaching to it the result. So in this case, this function is returning simply 1 as a result, and as you can see here, the name of the function used to pass back the result. And actually, when the definition is made, at the end you need to define, of course, that what kind of type you want to pass back with this function. In the second case, instead of using the function name to return the result of the function, simply let's say equaling or initializing the result variable, let's say, with 1, and this function is also giving back the 1 as a result, but of course here the not the name is used, but the result variable. And in this case, this is basically doing the same thing like the first function. The next one is a function where the parameter might be omitted, which means that if you are defining the parameter in the call, then it's okay, the function will take that parameter, but because here we initializing the variable or the parameter in the function definition with 0, if I'm not adding the parameter at the call of this function, then the function will be carried out with the constant initializing value, so in this case with a 0, and then it will return the result back with the function itself. The next one is when the parameter is starting with a const modifier, let's say, and this will tell to the compiler that this variable cannot be changed inside the function or procedure. So here I marked out these lines because actually if I would like to do this inside the procedure, this would immediately cause a compiler error, because the A cannot be redefined inside, so reallocated with a new value, and because this line would do that, the compiler would immediately show an error. So instead of doing this, you can define another variable inside the procedure, a local variable, using the A parameter, which is the constant parameter, and then you can basically use the result in the procedure or even function as you want. So basically here this will work in this way. Also, you can pass an array to a procedure or to a function as well, and then of course you can use this array to do something with it. In this case, I'm passing an array of strings and then writing out all the strings after each other. So in this case, of course, you can also pass an array with a certain length, but inside the procedure, it will consider it as an open array. So an array which doesn't have a defined size. The next two procedure is about typeless parameters. Typeless parameters are parameters where basically you are not defining what kind of parameter you want to pass to the procedure or function, and in this case the parameter itself is not passed directly to the procedure or function. Only the memory address or pointer to that parameter is passed to the procedure or function, and basically you need to work with that variable as a pointer, and then you need to handle it based on what type you were using. But of course, because here the type itself is not defined for the parameter p, it is hard to identify or even impossible to identify that which parameter is or which type is basically passed to the procedure. So in this case, the first procedure, what I defined here as a typeless parameter with a constant p, and the second parameter is a string parameter, where I tell to the procedure that how the p should be handled, or the constant parameter should be handled. And to also show an additional thing when procedures or functions are defined, in the Pascal compiler, the procedures or functions are basically compiled after each other, and because you might have the case that in one procedure you want to use another procedure on another function which is defined later in the code. You need to tell to the compiler that this procedure or this function will be defined later on with its code, and this one you can do with this forward statement here. So as you can see that I was defining actually the typeless param function or procedure 2 times, and this let's say coding practice called overloading. So when you are basically defining 2 different functions, 2 different type of calls, let's say. So at first, as you can see, that I need to pass to the function or to the procedure 2 parameters, but I can also use this procedure to pass only 1 parameter. And in this case, if I'm using only 1 parameter and then I'm handling this as a string, so if I want to use this procedure, I need to pass a string to this typeless constant. So when I want to interpret the result or interpret what is at this pointer in the code or in the application, then I need to know if that was a string or not. So I need to pass a string to this definitely, otherwise the result will be misinterpreted. And I will show the example what does exactly mean. So as you can see, I define this second typeless param call for the strings here. So when I'm defining as well the parameter type passed to this function with 2 parameters, then I can get or I can use a string, or I can use an integer value. And then if I use a string, I can call the second version of this procedure to basically write out the parameter value itself. So in the other case, of course, if I'm using an integer passed to the constant p, then I can handle it according to a p, and I can write out like an integer, and I can print it out accordingly. So basically, these are the different options or different ways of defining functions and procedures. There are some additional things like external definition when you already have an object, a compiled object, or a dynamic link library or something like that. Then you can also refer to this precompiled functions and calls, and you can define this, but I'm not going into this right now because these are even, let's say, more complex programming techniques. So let's go to the application itself, where I'm basically writing out or using these defined procedures or functions. So you can see that at the first time, if you have a simple procedure where you don't have any parameters, then the call is also very simple. You just name the procedure, and this procedure will be called when the program reaching this line, and then it will do what is defined inside the procedure. In the second case, I was passing a string to the procedure, and then this is written out. So basically that's a simple variable itself. The third one was with the variable definition. So here I initialize the C integer variable with a 2, and this procedure is calling the procedure with the C value, and because the procedure is passing back the result of the calculation inside the procedure to this C variable, when I'm running the application and writing out the C itself, then we will see a 3 here. And actually this is the difference, of course, between the functions and the procedures, because the procedure you need to call outside of this write-ln, but if I would have the function or this procedure called as a function and would return a value, then I would be able to use it. So actually here in these lines you can see that when a function is called similarly with the procedure, then here I can use the function itself in the write-ln, because this will pass back a value with the function call. So here the same for the function. So here I had, the simple function was returning the result basically via the function name, and the second one was passing the result with the result variable inside the function. The next line was the parameter with a constant or initialized variable. So here I'm not passing anything, and the function we use the predefined 0 value, and of course inside I had the parameter times 2, so 0 times 2 is 0, of course, and here we will see the 0. And here I'm calling the same function, but here I'm giving a value to the variable or to the parameter, and then here I will get a 4 as a result, so the 2 will be multiplied by 2. The constants parameter, so here I'm passing the 10, and if you remember what was defined here, that the 10 will be or 2 will be added to the 10, and that will be the b value, and the b value will be written out. So here I will get a 12 when it was running. The next one is the string array. So here I define the st string. So I was defining here 2 lines, 2 string elements for the array, and then I'm calling the print array with the array let's say the dynamic array, which doesn't have an exact size defined originally. So then the last one is the typeless parameter calls. So the c is an integer value, an integer variable, and here what needs to be mentioned that the typeless parameter calls or typeless parameter values cannot use constant values. So here I cannot change the c to 2 because in this case the compiler would run into a failure. So if I'm compiling it, the compiler immediately telling that this cannot be a constant value here. So I need to pass here a variable, even if it will be defined as a constant. And why it is happening? Because for the c value we will have a defined let's say pointer with which I can use in the calls. So the first parameter calls or typeless parameter call, as you can see that I'm using here the definition where I'm using the two parameters, and here I'm only using one parameter. So here I cannot pass for this one the c value. I will show that as well what happens in that case, because this procedure will handle the parameter as a string and try to write the string based on the pointer what the procedure received. So running the application and checking the output, you can see that the simple procedure call was just writing out a text, so that was what was inside the procedure. This second one was getting this line as a parameter and writing it out. And then the next one was the return variable, where the c was initialized as 2, and then when I was calling the parameter, the c value was increased, and the procedure was passing back the result into the c variable. So when I was calling it twice, then and writing it out, of course the number was increased one by one. The simple function call was just returning a 1 in both cases. Then the next one with the constant parameter, it was the 0 first time, because I did not pass any value here to the function, so it was using the predefined 0. And the second one was using the 2, and multiplied by 2 was the 4, and so on and so on. So I'm not going through the rest, but you can see here the results. And here what is interesting is, of course, the typeless parameter. So the c was already 4 here, and then the procedure got the pointer of this variable, so the memory address of this parameter, and then it is converted into an integer value. In the second case, the string was passed, and here with this one again a string was passed directly to the second version of the procedure call. So just to show what would happen if I would change this to a C, so to the 4, and the procedure is trying to interpret this integer value as a string, but of course, because it's not a character, as you can see, it's immediately creating a runtime failure, because it cannot be converted back into a string value. So here I need to change this back to to the string, so one of the string from the array, and then of course the application would run without a problem. So that's all about procedure and function definitions. I hope you enjoyed the tutorial, and if so, then please don't forget to subscribe to my channel for future contents. And with this, I wish you happy coding, and see you next time. Goodbye.